types of rocks, volcanoes, and earthquakes. So let us revise these topics again and answer the questions. What happens when earthquake occurs? So the answer is when an earthquake occurs, seismic waves are created. Second, how are igneous rocks formed? So we know that igneous rocks are formed through the cooling and solidification of magma. Question number 3, what is a volcano? A volcano is an opening in the earth's crust through which lava, volcanic ashes, and gases escape. Question number 4, which materials come out during a volcanic eruption? So answer is during volcanic eruption, magma comes out. Next question, in which state of matter are these materials? Are these materials cool or hot? Why? So the answer is magma is extremely hot liquid and semi-liquid rock, as interior of the earth is very hot. Students, let us carry out this activity. Boil half a liter of milk. When the milk comes to a boil, switch off the gas. Keep a lid on the vessel. What do you observe? So now here we have to boil half liter of milk, and when the milk comes to the boiling point, just switch off the gas. Then after that, keep a lid on the vessel. Now we have to say what did we observe over here. So before boiling, the milk was in liquid state. After it came to a boil, steam started coming out from it. Even you have noticed when you boil milk. So after some time, a thick layer of cream develops over the milk. So here you can see a thick layer of cream has developed over the milk. The temperature of the cream is lesser than the milk below, which means that this layer is very much cold as compared to the milk which is there down. Thus, it can be implied that the creamy layer cooled faster than the milk below it. A similar process occurred when the earth cooled. So, the scientists believe that the earth was a gaseous balloon. It cooled down as it rotated around itself. So, as we know that the earth rotates around itself, so the temperature slowly cooled down. The process of cooling took place from the outer surface towards the earth's center, and the cooling process started from the outer surface. As a result, the outer layer of the earth became cooler and solid. But as we move from the surface to the core, heat increases. So, the outermost layer is much cooler as compared to the layer which is inside, or the surface which is inside. So students, as we saw in the previous example, that is in boiling of the milk, we saw that the temperature of the cream is lesser than the milk below. So in this lesson, we are going to learn about the interior of the earth. Students, man has always been inquisitive about what lies in the interior of the earth. A direct observation of the earth's interior has not been possible as yet. Through various methods, the scientists have tried to estimate about the same. To infer about the study of materials coming out of a volcanic eruption and seismic waves is very important. Matter coming out of volcanic eruptions consists of hot magma, gases, steam, etc. When lava cools and solidifies, igneous rocks are formed. Through the estimates of the study of temperature, density, gravitational force and pressure, the interior of the earth was understood. For instance, when we go deep into a mine, we feel an increase in temperature. Similarly, the magma coming out of volcanoes from the Earth's interior is hot. Such estimations were made by the geologists. Several earthquakes occur in various places on the Earth every year. Seismic waves are generated. These waves travel through the interior of the Earth. The study of their direction and velocity help us to estimate about the interior of the Earth. Man has also tried to dig deep boreholes in the interior to know about the same. Students, do you know our Earth was formed approximately 4.6 billion years ago. Initially, the Earth was in a gaseous state. It started cooling through the process of radiation. The Earth then liquefied. With time, the outermost part of the Earth cooled first and became solid, as we learned previously. This outermost layer of the Earth is called crust. Even today, outer planets of the solar system are in a gaseous state. So, students, let us start with the layers of Earth. As you can see in the picture, these are the layers of Earth. The Earth is formed with several layers of material. These layers are arranged one on top of the other. So as you can clearly see over here, they are arranged one on top of the other. And the Earth is formed of several layers of the material. Let us know what are the names of these layers and what are the material they composed of. So first is the crust. Now this layer which you can see that is at the outer side is known as the crust. The second one which is here is known as mantle. The next layer, that is the third one, is known as outer core. And the last layer which you can see, it is a shape of a ball or a circle. It is known as the inner core. Students, let us learn about this before starting with the layers of the Earth. These are the elements found in various layers of the Earth's interior, which means the elements which are present in the different layers of the interior of the Earth. So, the first one is silicon and it is represented as Si. Then aluminium, it is Al. Silicon again is Si. Magnesium is Mg. Nickel, Ni. And ferrous iron is Fe. And the density is shown over here. So it is from low to high. So it is starting from here, that is from low, and then it start becoming higher. So students, we will start with crust. So as you can see over here, it is the crust. So the uppermost layer of the Earth's surface is the solid crust. So this portion is the uppermost layer of the Earth's surface. The thickness of the crust is not same everywhere. So the thickness you can see over here is of the crust is not same everywhere. And why it is not same, we will learn in the next few points. The crust is the thinnest of all the layers when compared to mantle and core. So this crust is the thinnest layer as compared to mantle and core, which is the next different layers of the Earth's interior. This one is the most thinnest layer of all. So students, the thickness of the crust below the continent is from 16 to 45 kilometer and 40 kilometer under the mountain ranges and less than 10 kilometer under the oceans. The Earth can be divided into two sublayers, that is oceanic crust and continental crust. Now let us learn what is oceanic crust and continental crust. So the crust is classified into oceanic crust and continental crust. So here in the picture, you can see continental crust over here. This thick portion is known as the continental crust. And here you can see sea, that is ocean, and under that there is this portion. This portion is known as the oceanic crust. So oceanic crust, it is the crust beneath the ocean, and this layer is approximately 7 to 10 kilometer thick. So the thickness of this layer of this crust is approximately 7 to 10 kilometer thick. Continental crust. This crust can be as thick as 30 kilometer. So as you can see clearly in the picture that this one is thinner, and this layer, that this crust is much thicker. The earth crust is thinnest in valleys and thickest in mountain ranges. So now here the earth crust which is there in valleys is much thinner, and the earth crust which is there in mountain ranges is the thickest of all. Oceanic crust. Oceanic crust is composed of two minerals, silica and magnesium. So students, remember that we learned elements found in various layers of the Earth's interior. So yes, so these are the two elements which the oceanic crust is composed of. So that is silica and magnesium. This is silica and this is magnesium. So remember, oceanic crust is composed of two minerals, that is silica and magnesium. The combination of these two elements give other name as SiMa. That is silica is Si plus magnesium, that is Ma, and it results in SiMa. The oceanic crust is composed of SiMa. The density of this layer is 2.9 gram per centimeter cube to 3.3 gram per centimeter cube. And two rocks are mainly found, that is basalt rock and gabbro rock. Continental crust. Continental crust is composed of two minerals, silica and aluminium. So the continental crust has two elements or two minerals, that is silica and aluminium. So this is silica and this is aluminium. So students, what is the name of silica? Another name, that is Si, and aluminium is Al. So let us see what is the other name of it. The combination of these two elements give an other name as Cl. That is silica Si and aluminium Al is equal to Cl. The continental crust is composed of Cl. So students, the density of continental crust is 2.65 to 2.90 gram per centimeter cube. And granite rock are mainly found in this layer. So this is granite rock. There is a discontinuity between the continental crust and oceanic crust. It was first deduced by a scientist called Conrad and is named after him as Conrad discontinuity. So remember, the Conrad discontinuity is about discontinuity between the continental crust and the oceanic crust. Now next, there is discontinuity between crust and mantle too. As we saw here that there is discontinuity between continental and oceanic crust, then there is discontinuity between crust and mantle too. And this continuity is deduced by the scientist called Mohorovic. It has been named after him as Moho discontinuity. So remember, Conrad discontinuity is about discontinuity between continental and oceanic crust, and Moho discontinuity is about discontinuity between crust and mantle. Next is the discontinuity between mantle and core too. It has been named after Gutenberg, a scientist who discovered. So Gutenberg is about the discontinuity between the mantle and core mantle. So students, as you can see over here, this is the next layer, which is known as mantle. This layer is below the crust. So mantle can be divided into two layers, that is upper mantle and lower mantle. The upper layer is more in liquid state. So the layer that is an upper layer is more in liquid state as compared to the lower layer. When the Earth's crust gets ruptured, the hot molten magma, ashes and gases come out. So here students, as you can see over here, that the Earth's crust is ruptured and the hot molten magma, ashes, gases are coming out. This results in the formation of volcano, and because of this process, the formation of volcano is resulted. The magma that is released on the surface of the earth is known as lava. So this magma which is coming out from the volcano is called as lava. So students, it is through magma chambers that magma comes out on the earth's surface during volcanic eruption. So as you can see over here, this is the magma chambers, and from here you can see that these magma are coming out on the earth surface during volcanic eruption. The magma is semi-solid and can flow, as you can clearly see over here, and as you saw in the previous video also, that the magma was flowing from the volcano. These magma chambers are found in the upper layer of the mantle. In this layer, it is inferred that the temperature at the depth of 2400 to 2900 kilometer depth would be around 2200 degrees Celsius to 2500 degrees Celsius. So students, here the temperature of mantle is about 2200 degrees Celsius to 2500 degrees Celsius. So you can imagine the heat, the temperature this layer is having. And as it also consists of magma chambers, so you can imagine the heat in this layer. It is estimated that this layer extends up to a depth of 2870 kilometer. So the depth of this layer can be also extended up to 2870 kilometers. Epicenters of deep-seated earthquakes are usually found here. Mantle begins at a depth of around 42 km of the Earth's surface. Internal energy released due to the endogenetic movements occurring in this layer is responsible for mountain building, rift, volcanic eruptions, earthquakes, etc. The average density of this layer is 4.5 gram per centimeter cube, and it increases with depth. The density of lower mantle is about 5.7 gram per centimeter cube. So students, this is the crust, and the crust is divided into two sublayers, that is continental crust. This is the continental crust, and this blue color is the oceanic crust. The thickness of the oceanic crust is about 7 to 10 km, and the thickness of the continental crust is about 30 km. Then after the crust comes the mantle. The thickness of the mantle is around 2870 km, and the mantle is further divided into upper mantle and lower mantle, and the magma chambers are also found over here, that is in the upper mantle, and the temperature over here is about 2200 degrees Celsius to 2500 degrees Celsius. Okay, so now later comes the core. So now this orange color part, as you can see over here, this is the core, and it is further divided into outer core and the inner core. And this point, as you can see over here, is the center of the earth. Okay, students, so let us start with core. So these two are the cores. The core starts from around the depth of about 2900 km from the Earth's surface. So as we know, first is crust, then mantle, then core. So the core starts from around the depth of 2900 km from the Earth's surface, and the thickness of the core is about 3471 kilometers. So the depth is around 2900 kilometers from the Earth's surface, and thickness is around about 3471 kilometer. The core consists of an outer core and the inner core. So this part over here is the outer core, and this is the inner core. Students, as you can see over here, these are the layers of the earth, and this part is the outer core. So this is crust, this is mantle, and this is the outer core. The outer core lies just below the mantle, and it is made up of nickel and iron. So this outer core lies just below the mantle. This is the mantle, and here comes the outer core, and it is mainly made up of nickel and iron. So the combination of these two elements gives other name as knife. How knife? That is, nickel is Ni and iron is Fe. The temperature of the liquid outer core is around 500 degrees Celsius. So here, as we know that nickel and iron are higher density elements. So the temperature of the liquid outer core is around 5000 degrees Celsius. The density of outer core is 9.8 gram per centimeter cube, and the temperature of the liquid outer core is around 5000 degrees Celsius. So students, as we learned that the outer core of the Earth's interior is in liquid state, and the proportion of iron is more in the outer core, and because of that, vertical currents originate in this layer. This is the another characteristic of this area. You can say it as in this also. So the difference between the temperature of the outer and inner core give rise to vertical currents. So it originates vertical currents over there. So the earth rotation gives them eddy circular motion, and electric currents develop in these spiral edgings of the liquid iron, and thus magnetic field is generated. So here, as you can see, these blue things are magnetic field, and this magnetic field of the earth is functional even outside the earth's surface to a certain distance, and it is sometimes called geodynamo. So you can see these magnetic fields which is generated, and it is outside the earth surface. As a result, a cover develops around the earth because of the magnetic field. So because of this magnetic field, a cover develops around the earth's surface. The earth atmosphere is protected from the solar wind. We all know that the Earth's atmosphere is protected from the solar wind that is coming from the sun. So the magnetic field thus developed is called magnetosphere. So this layer is known as the magnetosphere. It is not layer, but it is known as the most important sphere of the earth, and it is the fifth sphere of the Earth. It is known as Earth's magnetosphere. So now students, this is the geographical equator, and this side, the poles which you can see over here are the geomagnetic poles, and this is the equator. This is geomagnetic axis. Okay, so the magnetic field of a bar magnet is strongest at the north pole and at the south pole of the magnet, and the force is weaker in the middle of the magnet and halfway between the pole and the center. So now, if you look at the diagram, you can see that there is inclination of the earth field is 90 degree at the north magnetic field and 90 degree at the south magnetic field. And the magnetic equator is the line where the inclination is 0. So the Earth's magnetic field is also known as geomagnetic field. Now student, this is the inner core. Let us revise. This is the crust, mantle, outer core, and this is the inner core. So let us study about inner core. The inner core is more hotter than the outer core. So as we know, as deep we go, the temperature increases. So the inner core is more hotter than the outer core. Inner core extends from around 5,150 km to the depth of around 6,371 km. That is the Earth center. So here is the Earth center. The temperature in the inner core range from 5,000 degrees Celsius to 6,000 degrees Celsius. So it is much hotter than the outer core. Inner core is composed of two minerals, that is iron and nickel. So again the combination of these two will be knife, that is iron Fe plus nickel Ni. Then the inner core is in solid state. So students, as the material in this layer are under extreme pressure, the inner core is in solid state, and therefore the temperature here is almost equivalent to the surface temperature of the sun, which means the temperature of the inner core and the temperature of the surface of the sun is equal. So you can imagine the heat, the temperature which this inner core is having. The density of this sphere is around 13.3 gram per centimeter cube. Okay students, this is the crust. This is the mantle, in which it consists of upper layer and lower layer. This is core, this is outer core, and this is the inner core. And this is the center of the earth, which is about 6,371 km. Always remember, observe the velocity curve of the seismic waves. So now this is the velocity curve of the seismic curves shown in the figure. The left curve in figure A shows the velocity of secondary waves. So this left hand side curve is the velocity of secondary wave, and the curve on the right is the primary wave. This is the primary waves. There are many changes occurring in the curve of secondary wave. As you can see that there are so many changes occurring in the curve of the secondary wave. The curve drawn with the help of dots shows the average velocity of the wave, and you can see pink colored dots over here. These are the average velocity of the waves, and the average velocity is shown for both the waves also. And you can see over here the secondary wave has ended. Changes are visible even in the curve of the primary wave, and you can see there are certain changes which are visible even in the curve of primary wave. The velocity of the primary wave increases according to depth till 2900 kilometer. So now you can see the velocity of primary wave increases according to the depth. The velocity of secondary wave is around 6 to 8 km per second around the boundary of the outer core. So now as you can see over here, the seismic wave is around these 2 km per second, and here it has been stopped. The curve has been stopped. These waves do not enter the core. So as you can see this line, from here the core starts. So it has not entered the core. But when it enters the core, the velocity reduces. Now as you can see, as the primary waves entered the core, the velocity reduced to 8 km. It was going till around 12 km, and suddenly it reduced to 8 km, which is over here. So see this as shown in the dot curve. On the basis of these curves, the scientists have inferred the density of various depths. So because of the seismic waves, the scientists have inferred the density at various depths. So student, now figure B. The density curve of the Earth's interior is shown in the figure. This is the density curve of the Earth's interior is shown in this figure. This is the density curve and this is the depth in meters. Red curve in the figure B shows gravitational force at various depths. So this color curve is showing the gravitational force at various depths. So now the gravitational force increases at certain depth. So as you can see, the gravitational force increases at certain depth from the surface, and then again it reduces according to the depth. At the center, it is 0 as is visible from the curve. Let us revise. The Earth is made up of several different layers of material. The outermost layer is the crust. The crust is classified into oceanic crust that consists of sigma, continental crust that consists of Cl. The next layer is called the mantle. The outer core is made up of nickel and iron and it is called knife. The material in this layer is in liquid state. The inner core is solid and have very high temperature and pressure.